Hi, this is Julie Harland. Please visit my website at yourmathcal.com where I organize my videos by topic. A fraction that contains one or more fractions in either its numerator or denominator or both is called a complex fraction. So below are 5 examples. The first example, we have 3/4 over 5/8, so it has a fraction in the numerator and a fraction in the denominator. The second one, there's an x alone in the numerator, but in the denominator, there's two terms, 2 minus x over 3, so there's a fraction there. And you can see from the third, fourth, and fifth examples, I have fractions in both the numerator and denominator. Complex fractions are not in simplified form. That means we can simplify further so they don't look complex. And there are two commonly employed methods we could use. And these are a quick overview of the two methods. The first method is to write both the numerator and denominator as single terms or fractions. And then you'll multiply the numerator by the reciprocal of the denominator. The only one in the examples above where you already have the numerator and denominator written as a single term or fraction is the very first one. We have just a single fraction in the numerator, 3/4, and a single fraction in the denominator, 5/8. All of the rest of them are not in that form. If you look at the fourth example, 1 over x minus 2 over x squared in the numerator, there are two fractions in that numerator separated by a subtraction sign, so that's not a single fraction. And in method 2, you don't need to have it in the form as the very first example up here. Instead, to simplify the complex fraction, the first step would be to multiply the numerator and denominator by the least common multiple of all the denominators of all the fractions in the numerator and the denominator. We're going to simplify this complex fraction using the first method because I have a simple fraction in the numerator and a simple fraction in the denominator. So that really means this division bar, you see, the big fraction bar means divided by. So if you want, you can do this first step, that's up to you, where you write it using that division symbol with the two dots. And then when you divide by a fraction, it's the same thing as multiplying by the reciprocal of the fraction after the denominator. So that would be 8/15 times 25/4. All right, so now we're down to multiplying two fractions, and so we use our rules for that. I'm going to do this by canceling. 4 divided by 4 is 1, and 8 divided by 4 is 2, so I divided each of those by 4, and let's see. For 15 and 25, I could divide both by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. And so in the numerator, I have 2 times 5, which is 10. In the denominator, I have 3 times 1, which is 3. And we just leave our answer as a fraction. No need to write it as a mixed number. In fact, usually it's preferred that you leave it in that form. Okay, that was method 1. Now the second method, I'm going to rewrite this problem, 8/15 over 4/25. Uses a method where you multiply the whole numerator and whole denominator, see there's a big numerator and a big denominator, by the least common denominator of all of the denominators. So in the numerator, there's only a denominator of 15, and in the denominator, there's a denominator of 25. And so you have to figure out what the least common multiple of 15 and 25 is. All right, so one way I figure it out is I build it up. I know to get 15, I need 3 times 5. And to get 25, I need a 5 times 5. I already have 1 5, so 5 times 5. So this number must be the least common denominator, 75. And you might be able to, you could call the least common multiple of the denominators or just the least common denominator. So you multiply the whole numerator by 75 and the whole denominator by 75. This is simply making an equivalent fraction because 75 over 75 is like multiplying by 1. So I'm just going to distribute. And when you do this, the reason this works is because 15 will go into 75 and 25 will go into 75. So we're going to get rid of our fractions in the numerator and denominator. So I have 75. Oops. Sorry. Kind of moved over. Okay, so we have 75 over 1 times 8/15. It's up to you whether you need to show this stuff. And 75 over 1 times 4/25. And then I am going to cancel. The 15 goes into 75 5 times. And the 25 goes into 75 3 times. So in my numerator, notice I have 5 times 8, which is 40 over 1, and that's simply going to be 40. No more fractions in the numerator. And in the denominator, I'm going to have 3 times 4 over 1, so I'm going to have simply 12. And the last thing we need to do is to reduce this fraction. So 4 goes into both of these numbers, so you could just divide numerator and denominator by 4, or you could do your canceling some other way, and I'm still going to get 10/3. So that's how we do 8/15 over 4/25. We take that complex fraction and we simplify it using either of these two methods.